Facial recognition.
Facial recognition works by something called computer vision.
But what's the maths behind it?
In 2001, the Viola-Jones algorithm was created by Michael Jones and Paul Viola to develop facial recognition software.
The algorithm is used for facial detection. It has 4 stages: half feature selection, creating an integral image, AdaBoost training, and cascading classifiers.
The algorithm first uses half features, several different features which compare the light and dark areas of the image to determine whether it is a face or not.
The same technique is applied to face detection. For example, this feature shows that the bridge of the nose is lighter than the eyes on either side.
The algorithm then generates a sum of values in a grid, known as the integral image.
This is the algorithm. It means that the value at xy in the grid is the sum of the pixels above and to the left of it, where xy is the value of the pixel at xy.
Now that's a lot of maths to calculate, so let's give an example so it's easy to understand.
Each number represents a pixel in the image. The algorithm calculates the sum of pixels above and to the left, so let's add up to create what's called our integral image.
So 17, for example, is the sum of the numbers in the red square, 26 is the sum of the green box, 68 is the sum of the blue box, and 113 is the sum of all the numbers in the grid.
This is called machine learning, and the most commonly used algorithm used for this is called AdaBoost. It works by turning weaker classifiers into stronger classifiers that can easily separate terms accurately.
The next step is using cascade classifiers. Classification means putting objects into classes based on some property they have.
The image goes into the system which performs the first test to see whether it's a face or not. If it fails this test, the image is not a face. If it passes the test, it will continue to the next 100 or so tests until the only images left are faces.
Local binary patterns are used to recognize differences between pixels to generalize what a face looks like using 8-bit binary. The numbers in the left grid, representing pixel brightness, are converted into ones and zeros, which the computer can then read.
We got in contact with Tony Porter, the surveillance camera commissioner for the Met Police, and he said that, quote, "The algorithm allows a video image to cross-check against that list and perhaps identify someone in it, perhaps a criminal who is wanted by police." For our final product, we decided to opt for a program that can be downloaded into webcams using Python to recognize and label faces. This webcam can be installed into doors and can be virtually used as a hand-free door lock.
It will work by scanning registered people's faces, and if it recognizes their face, it will let them in. If not, it will trigger a silent alarm and send notifications to the owner. This solves a big safety and privacy concern, as there won't be any door keys or fob to worry about losing or getting stolen. This also prevents break-ins, as it alerts the owner quickly yet quietly when it spots unknown faces.
It is aimed at people worried about home security, specifically the elderly. Here is the CAD for our product, which we have created using Google SketchUp. The facial recognition camera is equipped with a Raspberry Pi camera and circuit board.
Here is a sample of the code used in our product. In our code, we have used cascading classifiers, matching faces to names, and facial recognition in real time. Introducing Face Lock. We make unlocking the front door effective, easy, and efficient using facial recognition. Stay safe with Face Lock, the key to the future.